Hi guys, today we are going to talk about another interesting sliding window question, minimum window substring. If you can do this question, for sure all sliding window question will be pretty easy for you. Let's see what this question is all about. Alright, so what will be our approach? First we will understand question. Then we will look at what possible question we may ask to clear our doubts. Then we will see that how we know that sliding window applies to this question. Like what triggers us that, oh, we can apply the sliding window. Later we will see if we will use a sliding window, how it will work with that. Because once we will apply that, it will take us to the next level, that how we have to write the code. And then we will look at how we will apply the coding template. And in this coding template, I'm using Scala. I will be using functional programming, and for sure I'm using the same coding pattern, which will be the sliding window. So in that case, you can use this coding pattern and you can apply on any language of your choice. Now let's see what this question is. So you have given two strings, S and T. We were expecting a minimum window substring from S with one condition, that in that substring, all characters from T must be present, and for sure it will be minimum. So you can start your discussion with the question. So once you hear that question, so don't start your code. You have to wait, you have to get the information correctly, and then you have to proceed. So this is how they will judge. The moment you will start asking the question, that moment the interviewer will start predicting you that how you approach some problem. So you must ask some question. Let's suppose if you can ask, what if T is greater than S? Is it possible? They say no. Or any string may null. They might say no, it's not possible. That can be empty string but not null or something. So does order matter? Order matter means, so before asking this question, third one, maybe it will come later. You can start your discussion with a very simple example. Let's suppose you can say, what if T is equal to A and B and S is equal to A? So by providing the input, you are asking that, okay, is it the output you're expecting or something from this S string? So you may ask, let's suppose you can see in this S, A, C, B could be the possible candidate where all characters are coming in that substring. This is the substring, and A, C, B, you can see all characters of this T is visible like A, C, B. They're coming duplicates. But we are expecting another condition, which is minimum window substring. In that case, they're expecting A, C, B will be the right answer. Now, if you ask this third question, what I was talking about, that does order matter? Order matter means that this T has character A and B. Or are you expecting from this substring that this, like A should come first in that substring, B should come later, and in that case, B, C, A will be a wrong answer. Are you expecting this or no? They will say, no, your order doesn't matter. And in some example, it will be like, for duplicate example, if I will say A, B, C, in that case, B, now in this example, if you will see A, B, C is T, this is T, and S is that one. Now in that case, you will see that the minimum window will be B, E, A, D, C. That will be the minimum window which we can give as an answer, because in that frame only, that window size, we have all characters. And now you can see that here A is repeated twice. So that will be the required answer, but we can't find any other solution because B is here, C is there, and inside A is packed twice. So we have to take them twice. But that's the minimum window substring that satisfies this condition. Now let's go with the third point when we are saying that how we come to know that we have to apply the sliding window to this. So in sliding window, we have talked about that any question which is giving you some string or some array, and they're talking about or asking about some subarray, or substring, and there is some condition involved with that, and also there is some size is also considered. That size may be given or may be expected. Now let's map this question with all these 4 points. The first thing you can see, in that question they have provided as a string. They are expected, the first condition exactly satisfied, so we are happy with that. They're expecting some subarray, they're expecting some substring. Minimum window substring is required, so they are expecting some subarray, so exactly the second condition to satisfy. Now the third point, they're looking for some minimum window substring, that's a condition. And another condition, which is that they're looking that all characters of T must be present in that substring. So there are 2 conditions actually involved. The first is they're expecting it should be minimum, and the second, they're looking for that all character of T should be the part of that substring from S. Now this K is actually the size of window. So in that case, this condition minimum is telling the size of K. So we are good with all these 4 conditions, because the minimum is telling that what will be the window size, which should be minimum. That could be maximum also, but it's the minimum. But in that case, we come to know that we can apply sliding window. So once in any question these 4 conditions are applied, you can find that, oh, you sense there are these 4 points out there. I can try with the sliding window. Now let's see how we will apply sliding window to this question. Okay, so how we will do sliding window. So I have just mentioned a few points here. Maybe you can read, but I'm just saying all these things here also. So let's pick some simple example. Let's suppose this one. This is AACBD and AB. So now we have to find these 2 characters in minimum window substring from that S. I have just mentioned here the same example. Now what we do actually normally in sliding window, we take 2 pointer. I will take my left pointer here at the very start. I'll pick the second pointer and I will say, okay, both are on the very start. Now I will keep it moving right until I will find some solution. So I will say, okay, go to the next step. Now when we are thinking about it to move the pointer to the next step, I first need to know that what we were expecting. Like on each step, I need some information, I need some data structure on every step which tell me that am I achieved what was expected. So what I will do might be, it depends how you approach, but I think that we should use some map at the very start which tells the count of each character. Like A should be 1 we are looking for, and B we are looking for 1. Now this is what we are expecting at the very start. Okay, there should be some data structure which tells us some information on each step, that have we achieved what we are expecting or no. So this will help on each step. So whenever we will move the pointer next, we will update that map. We will look that in the code that how we'll do that. But for sure, there it comes in your mind that there is some data structure required. On each step, I need to confirm something, so better I can use some data structure to store my information. Now let's go with the next step. Now once we have moved the pointer, we have already found A, but this time you can see the A has came twice. Now 1A is extra. Now that extra means we instead of reducing down to -1 or something, what we can do, maybe we can introduce some other variable, say needed, or might be we can say found, or like that. So it means that we are thinking that how many characters was needed or found if they goes to -1. So it means that we have some extra. There are some duplicates. So that will help us to reduce the size of window. Now consider the same thing here. In that case, we found 2A. 1A is extra. Now we will move this pointer further. We found nothing. And now we move further. oh, we found a solution. So once we found the solution in our substring, like here, this one is a solution which we found right now, A, C, D. But now we will look for this window. Does it is minimum or no? To go with the second part, is it minimum substring where we found all the characters from T? So what we will do, we will start moving the left pointer forward with each step, because up to right we have found the solution. So this is the boundary for that. Now we will move the left pointer to squeeze the solution to find if we could find something minimum. Now we will move our left pointer further. I say, okay, up to here, is it okay? So we said, yeah, we found it. We are satisfying that condition yet. But I think before doing that, what if we have found some solution? Why not we put 2 pointers there, which are the solution pointers, which say, yeah, we found the solution up to here. So these pointers might be, we can call them, let's suppose, start and end, which are telling the indices of that substring where we found some solution. Now when we will move this left pointer further, we will say, okay, so we can say this is left pointer, this is right pointer, and that's one we are talking about. This is start, this is end. Now when we are moving our left pointer forward, so we still got some solution. So when we got the solution, even moving the left pointer forward, so it means now this is the better solution. This is more optimized. So what we will do, we'll move this left pointer forward, like this start pointer forward. We said, okay, we found another new solution, which is more optimized. And now in that case, once we will move this left pointer more forward, we found no solution. So it is breaking that all the characters of T is present in this substring. No, these C and B don't have A in it. So in that case, we will start moving right pointer forward again. We will say, okay, up to now we found whatever was required as a minimum substring. Now, right, it's your turn, you have to move forward. So now the right pointer will start moving forward. We found nothing. In that case, we will give the answer, which will be start and up to end. So that will tell us that the substring A, C, B is the minimum substring which we extracted from S, and that satisfies the condition that A and B are present. Now let's go with the second example. In this second example, let's suppose if we have like these string and we are again expecting A and B, what we will do, we will again pick left pointer here at the very start. We will take the right pointer on the next, like it will be also in start. We'll pick our left and start and end both on 0 because we haven't found anything yet. What we will do, we will keep the left pointer here and we will start moving the right pointer forward. With each iteration, we have to update the map and we have to consider that do we have got or like more or less character? Is there some extra character or no? Can we exclude them to achieve the minimum substring? So this found variable is actually explaining us that can we exclude some character to achieve the minimum substring. So this is actually giving us this benefit. Now what I will do, I will keep on moving my right pointer forward. So I got no B yet. So I keep it moving up to here. I found a solution. So once I found the solution, so what I will say, so start and end will come to this point where we found some solution. I will put them here. And now what I will do, I will say start moving the left forward again. Start will come here. We found the solution. We will again update start and end because we found some better solution. Now right will keep on moving forward again. So no. Now left will move forward again. We found no solution. We are not going to change start and end. Now I will move my right pointer further, like go forward, never found A. Never found A yet, now found A, and here I found it. So once I found the solution, I again ask my left pointer, now it's your turn, move forward. It will move forward, still be valid, but that substring which we have found yet is still greater than what we have already found, which is the local minimum. Now we will keep our start and end pointer on the same place here, but we'll move our left pointer again. We'll say, okay, we found no solution better than what we have already in hand. So we will move the left pointer. Now once we'll move that, it is breaking the condition. In that case, we are expecting that the right pointer should have to move forward because we don't have B here. Left pointer is forward. So we will come with the final solution that A, C, B will be the best minimum substring from S which satisfy the condition. It has all characters of A and B. So that will be the approach. That's how we will apply this sliding window. And let's go for the coding template. We will keep the same template like as zip with index, which means that each character will be zipped with its index value. Let's suppose if we are talking about, so it means that we are going to achieve our zip with index A tupled with its index A and 0, C and 1, and there will be B and 2. So this is what we get as a zip with index. Now we will fold left, and here we will initialize all the values that we are expecting that we are going to change in each iteration. And here with a pattern match, we are assigning them the name to each of the value that we have assigned. So here you can predict that what possible values that you're expecting that you need to change. As per our discussion, you can see there should be some map which have the key value of T. We are expecting like char and int. There should be some map like this. There will be a left pointer. As we saw, there should be a right pointer. And we are expecting there will be a start and end, because start and end will explain that which will be the local minimum we have found yet. And we have to use a found character which will help to find the minimum solution, because it tells us that, okay, how many characters you can exclude. That's the limit we have achieved. And the main logic will be all here. When you are going to write the main logic, I will better explain that write your logic like a partially pseudocode, but pseudocode means you have to write the function. Whatever, let's suppose you want to achieve something here, just give the name of that function like update, required character or something. So give the name, don't pass any variables here because you can decide them later. But once you give the whole flow that this is how I am going to execute my whole flow, you can then go with each function later to provide the functionality. So you can mention that, okay, I'm going to do this, then I will do that. So you can keep on defining some function. You can break down your problem into different functions, like F1 we will do this, F2 will do that, and once you will keep on doing, then later you can jump with F1, F2 and F3 to explain the functionality. Let's go with the code and see how we can implement that. Welcome back. So we know that we have to apply sliding window for this question, and that will be the template. We will say string as zip with index, and then we will forward left. Here we will initialize some values. By using the pattern match, we will give them some name, and with each iteration we will get the character and the right index. This tuple we have got by this zip with index, and here will be our main logic. So as per our discussion, what we can do, first we can create a data structure, a map, which will tell that how many characters are in our T string. So we are saying a map, which will be a map of char and int, and we are saying T, so we are going to create a map, and that map will be t.group with group by with identity. Identity is a lambda function which say x to x. Like if we have, it's just like that, x to x. So instead of doing that, we will say identity, and I will map the values. I will get a tuple. So I will say we are going to map the values, like the first one is character and the second one is the string we have got. So we will say its size, length, and here we will get a map like this. This is how we get the map. Okay, so once we have this map, we will provide this for sure here. And what other things we are expecting? So as per our discussion, when we are talking about a sliding window, we know that we have to provide a left pointer, we have to provide a start, we have to provide an end. This start and end will be used when we found some optimize, like not optimize, but minimum window size. Other variables, yeah, we have to look for the found, and we have to provide this map. Now, these are the pattern match which will be given here. So what you are thinking about these values? So I think that we can initialize left at 0 index, start is also in 0, end is also in 0. So it means that if we never found anything, in that case we will return the substring which will be empty. And found, we have not found yet any character from S which maps with T-string. Now, what will be the map? So map is the one which we have initialized here. So this map we will provide, so I can just say tmap initially, just to give a separate name to not confuse with this one. So we provide the tmap here, and this is the name for internal iteration we are going to use for. Now, once we have this, everything that's in hand as per the discussion, so how we will implement that code. The main logic will be, we will think that first we have to update the map. We will say that we have to update map with new character. We have found a new character. We will see how many parameter we have to send it here. So we have an updated map which knows that if we have found a new character, so in that case I'm going to minus the count from this map which was required, which was needed. And now we will say new found, that how many characters, let's suppose if that was A and T was equal to AB, and like in this example we are saying, so once we have A here, so we found it. So once we have found that, so we can say, okay, how we will found we will see, but we can give the name to a function like that, found with new character. So we have found, how many found we have now? So it will tell like find needed with new character. So I just give the name like found with new character. And once we have this, now I can go with this procedural approach that I will say how many, like, okay, we have found the solution. So what I can do, like found solution, and then later I will say that, okay, minimize the window, like that. So in that case it will be a little bit more variables here, but I can initialize a simple one function. I say find min window, because with both of those functions like found solution and minimize the window, in that case those variables has to be updated. Left pointer will update, right will update. So we'll think that how many variables we are going to define for this. Now how we will update that map with the new character. So when we are talking about this map, so here once you look at here in the whole flow, we have updated the map, we are talking about how many new found we have, and then we are talking about like found solution, and then we are talking that minimize the window. But I just put them in one function that will return at the end all these character at the end, like all these parameters at the end, left, start, and found, and map. So we have, once we have everything here with the for left, we can map it like in this way. We don't need left pointer, we need from, we need to, and we don't need other parameters. We only need from and to. And at the end, what I can do from the s.substring, I can say use from and to. So that will give the minimized substring, window substring, which has all the characters of T. Now that will be the whole template, whole solution for that. So for this function, I just wrote it here. It just tells we will send him a character, that the new one which we have got, and I am going to send the map. So it will say if this character, the new one with the current iteration, if that is all it is contained in the map, it means that it is in t-string. So we are going to decrement that count. And if it is not there, it's like it is C or D, so I'm going to just return the same map. For the second function, which was written there, we need to send it our friend found. Currently, how many we have found, and we have to return it the character, which is the current character, and we have to return the new map once it was being updated. So what it does, this function is just saying that does this map contains that character, and so do we still need this, like this count is greater than or equal to 0. So in that case, I'm going to update found 1. Yes, we found 1, and otherwise we will return the same found. Let's go with that other function. Now with this third function, we are going to provide, it looks a lot of parameter. We can make it like a context class here, but I'm not going with that because for the interview, we can just go with all those parameters, and for sure we can just reduce them by making refactoring. But right now, let's see, we need with each iteration to find the minimum window is we have to provide the left pointer. We are going to provide left, we are going to provide start and right new found, and we have to provide the new map here. Once we provide all those parameters, we are going to return at the end, we will return left pointer, start, and then found. This is not right because right is changing with each iteration itself, and the updated map. So in this condition, what we are saying found is not equal to t.length means that we still need some character, or there are some character which is more than that. So if found is not equal to t.length, so we are just returning all those parameters as it is, just to go for the next iteration, to move the right next, to expand the window and try to find some new character if they are the part of t. Now what I have to do, I have to just say, well, if let's suppose we found that, yeah, found is equal to t.length, we have found all the character. What the first step we have to do? We have to update our start and end. So we are saying new start and new end will be with some function like update start and end. We will see what function we have to provide here, and then we will say, okay, once we have that, think about the left character, because this is the one we are going to exclude. So we are talking about the left character will be our s.left, and now we are talking about, okay, once we are going to exclude the left character, so now our left pointer has moved forward, so new left has moved to our left plus 1. Now here, once we are going to exclude the left character from the string, so our substring, what we have found, what do we have to do? We have to look for new found. Now, what is new found? Or have we excluded something which is the duplicate? We are going to find some new character like that. So we are saying found with excluding character. So we will see what parameter we had to pass here, and then we are saying, okay, what is the new map once we have excluded something? So we are saying update map with excluding char. So what parameter we can say? So we have found that, okay, what after excluding the left character from the string, what happened with the new found and what happened with the map, how they have to be updated. And if everything is done, so for the next iteration we are going to tail recursively calling that find. So here we will provide the new left, and we will say new start, we will say new end, and we will say right, and that pointer will be here, new found, and we are going to call with the new map. So this will call tail recursively until we are going to find the minimum new start and new string. So this recursive call is actually making the call again and again to try to minimize that solution to find the minimum window. Now, what about this function, update start and end? So this new function, update start and end, is going to look for what? It will say, give me start and end, and left and right, and I will let you know which window is bigger. So if this end is still like staying at the very start, so we never found a solution yet, so this is the first condition, or if we have moved already, so we are just looking for end minus start, is that difference is bigger than the right minus left, like because right minus left has found the new solution. That's why we came to in this block of else. So we are asking that does the new solution which was being found, is that window is less than the one we have found before, then left and right plus 1. Why right plus 1? Because you can say in the substring s.substring when you write this because this is 0, 1, 2, and you have to just mention just length plus 1 to get the substring of that, because the end part is excluded in substring. That's why I just write it plus 1. Otherwise, we are going to return the same, start and end. If we never like the start and end and start in the right place, like they are already on the minimum value, so we're not going to update that. Now let's say about this function. Now for this function, found with excluding character. So this function is doing what? It is expecting you give me the found and the character you're going to exclude and the map. So if from the map we are going to ask the question, does this map contain that character which you're excluding? And if you're excluding it, does its count has reached 0? So it means that what you're excluding is required by our answer. So if you're excluding some required character, in that case we are going to reduce this found. So we are saying found minus 1, else we will keep the found there. So we will provide all those parameters here. So we are saying we will give you found, we will give you our left character which we are excluding, and we will give you the map. Now for this function, update map with excluding character. So what we are going to do, we are sending the character, we are sending the map. This map says the character you have excluded from the substring, does I contain that? So it means that this is the part of this G string. If you are going to exclude it, so okay, I will make this count of equal like plus 1 because I need it. So we need more of that character, so we add it up. Else we'll return the map as it is. Now provide these parameter here. So we will provide here, we will say take the left jaw, which we are going to exclude, and here is the map, and give us a new updated map. And that's it from this code. Let's run the code and see if it works. Alright, so we found some error. I never put this equal sign here. Let's run it again. And another error with a typo, contains. Let's run it again. We gave the extra argument found. We have to remove it, and let's run this again. And it works fine. So after 3 errors which are typo, but as per the logic it was correct, we have done. Thanks. See you on the next video.